There's a kind of hush that belongs only to the deep earth. Beneath your feet, far below the stone and soil, the planet keeps its quiet rhythm. A slow inhale of molten rock, a patient exhale of new land. Volcanoes are the places where that rhythm becomes visible, where the hidden warmth of the earth rises to the surface and glows for a moment before resting again. Tonight, we'll listen to that rhythm, to the pulse of magma beneath mountains, to the slow alchemy that turns destruction into soil and heat into life. These are not stories of chaos, but of balance. How even the fiercest eruptions are part of a long, gentle breath that keeps the planet alive. So breathe with the earth. Let your pulse match its slow tempo, steady and kind. You're listening to Science in Stillness, where knowledge whispers to sleep. Far below the drifting continents, beyond the cool crust we walk upon, lies a realm of quiet fire. It is neither liquid nor solid, but something between. A place where rock flows so slowly that a single ripple might take centuries to move. Geologists call it the mantle, yet the word hardly captures its softness of motion. It is the Earth's deep breath, warm, viscous, alive. From time to time, a pulse forms within that breath. Heat gathers where dense minerals sink and lighter ones rise, creating convection currents, like slow streams beneath a frozen lake. These currents push and pull at the crust above, cracking it into vast plates that glide, continents riding on an unseen tide. The surface, which feels so still to us, is in truth a patient ocean of stone. Every volcano begins in that hush. Before flame, before thunder, there is silence. Molten rock accumulating in chambers, tracing paths through weakness and seam. Each movement is measured in inches per year, yet over epochs, those inches lift mountains. The energy that will one day burst into light begins here, in soundless preparation. Scientists once imagined volcanoes as underground furnaces, raging and chaotic, but measurements of seismic waves, the small elastic shivers that pass through Earth's body, tell a gentler story. These waves slow slightly where the mantle warms, revealing not fury but warmth, not noise but murmur. Instruments record the subtle tremor, and in it, geophysicists hear something like the Earth's heartbeat. In Iceland, in Hawaii, in the Pacific's long arcs, that heartbeat is steady. Some zones are hotspots, fixed points of rising heat that pierce the crust again and again, forming chains of islands. The Hawaiian Islands trace such a path. As the plate drifts northwest, each island cools while a new one forms over the same glowing plume. Creation, migration, rest, all happening slower than any tide, yet certain as breath. And what of the magma itself? It is not a uniform sea, but a mosaic of molten crystals and gas. Imagine honey warmed by an unseen sun, thick and glowing, seeping through invisible cracks. Its chemistry differs by place, some rich in iron and magnesium, others lighter with silica. Those subtle differences decide whether a volcano will whisper lava down its slopes or speak in sudden bursts of ash. The quiet beneath is not empty. It hums with minerals changing form, with pressures that could crush cities, with temperatures near 1,000 degrees Celsius, yet all enclosed, restrained, waiting. This waiting defines volcanoes more than eruption does. For every second of spectacle, there are millennia of silence, patience, and unseen movement. If one could listen closely enough, perhaps through the hum of your own breath right now, that subterranean motion might sound like a lullaby, a reminder that even forces vast enough to shape continents move with infinite calm. Meanwhile, At the edges of the plates, friction builds and releases in gentle tremors, like muscle twitches of a resting body. Some of these signals are so faint that only deep-sea seismometers can detect them, swaying softly on the ocean floor. They mark the places where magma stirs but does not yet rise, where the Earth inhales again, slowly. The hypothesis begins to take shape. Even in their fiercest eruptions, volcanoes remind us that creation and destruction are part of one slow, breathing Earth. The stillness below the crust is proof. Nothing in nature is entirely violent or entirely calm. Beneath both are patience and rhythm. As we drift into the next layer of this story, hold the image of that molten stillness, the glow that never sleeps, the warmth that waits its turn. The ground beneath you is not silent stone. It is a breathing memory of fire, a calm older than the sea. Long before there were continents to drift or oceans to cool their edges, the planet itself was a sphere of molten color, a newborn star's leftover warmth wrapped in gravity's slow embrace. The story of volcanoes begins there, in the afterglow of creation, when the Earth was still too young to know silence. In that early time, fragments of rock and metal collided endlessly, each impact lighting the surface anew. The heat from those collisions, joined with the decay of heavy elements deep within, forged a furnace that refused to rest. Yet even in that chaos, order began to form. The heaviest materials, iron, nickel, sank inward to make the core, while lighter silicates floated upward, cooling just enough to form a thin, brittle crust. Between them remained the mantle, a deep, glowing cushion that would cradle the planet's future restlessness. Scientists have traced this story through meteorites and isotopes, tiny clocks hidden in stone that ticked during the planet's birth. From these, they learned that the early Earth cooled faster than once imagined. Within a few 100 million years, solid crust appeared, and the first volcanic mountains rose like dark islands in a red sea of heat. Those primeval volcanoes were unlike any today. Their eruptions were vast, unfiltered, spreading seas of lava thousands of kilometers wide. Yet they laid the foundations of the continents we stand upon. Each eruption built a new layer. Each cooling hardened into the bedrock that would later host forests, rivers, and life itself. Destruction created the conditions for everything that followed. Even now, echoes of that ancient heat remain. The core still spins, generating both a magnetic field and a subtle pulse of warmth that seeps outward. When that heat meets weakness in the crust, it creates zones of rising melt, the birthplaces of volcanoes. The same energy that once blazed across the early solar system now hides quietly beneath our feet, wrapped in patience. There's a calm wonder in realizing that every warm beach stone, every breath of ocean steam, owes its existence to that original fire. The world's surface is only the cooled skin of something still glowing inside. When magma rises, it is not a violent invasion, but a memory surfacing, an echo from a time when the planet itself was young and bright. To imagine that heat is to feel the planet's heartbeat more clearly. It moves through the rock at a rate slower than thought, shaping landscapes that will outlast civilizations. A volcano forming today might still breathe warmth 1,000,000 years from now, long after its slopes have turned to forest. The hypothesis lingers here too. Creation and destruction are not opposites, but phases of one steady rhythm. The Earth's fire cools, then reignites. Continents form, then crumble back to dust. Each stage feeds the next. The cycle does not rush. It moves as if aware that time itself is infinite. As you breathe, Think of that, the patience of heat. The warmth inside the planet will outlive every wind and tide, every season, every life. Beneath all our noise and movement, the Earth still glows from its own beginning, quietly remembering the moment it became possible to exist. From this enduring heat, the first volcanoes were born, and from their ashes came oceans and air. Creation began in fire, but what remains is calm. Deep within the mantle, magma does not rush. It waits, a glowing fluid threaded through stone, moving slower than glaciers, rising only when pressure and chemistry agree. To human eyes, it seems trapped, yet to the Earth, time flows differently. 1,000 years may pass as a single slow exhale. The word magma comes from the Greek for thick unguent, something viscous, almost alive. It is not fire as we imagine it, but molten rock rich with minerals, silicates, oxides, gases. Within its currents drift crystals forming and dissolving, each a small record of the heat below. Scientists studying these crystals can read their layers like tree rings, learning how long the magma has lingered, how deep it was born, and how patiently it has waited before finding a way upward. This ascent, when it happens, is guided by density and buoyancy. Magma is lighter than the solid rock around it, so it rises through weaknesses, tiny fractures, ancient faults, seams of softer stone. But the journey is not swift. Many bodies of magma never reach the surface at all. They cool slowly underground, turning into granite, gabbro, and other crystalline rocks that someday, through uplift and erosion, will form new mountains. Even stillness becomes creation. Imagine, then, that a volcano is not simply a vent or mountain, but a gesture of the Earth's long patience, an accumulation of waiting that finally, gently, reaches release. Each eruption we see on the surface is only the briefest punctuation in a sentence written over millions of years. Modern volcanology uses seismic tomography, a kind of ultrasound for the planet, to map these hidden reservoirs. The images show vast chambers shaped like lenses or webs, connected by narrow conduits where magma slowly drifts. Some chambers refill over centuries, others over millennia. The magma pulses, cools, and rises again, its rhythm so slow it could lull a restless mind to stillness. When we speak of magma chambers, it's tempting to imagine caverns of open flame. In truth, they are zones of partially molten rock, a mixture of solid and fluid, thick, heavy, nearly motionless. The energy within them is immense, but it hums rather than roars. Over time, as gases dissolve or pressure shifts, some fraction of that melt begins to move upward, guided by gravity's quiet geometry. The patience of magma mirrors the patience of growth. A forest germinates, expands, dies, and renews. A mountain does the same, only slower. The minerals that crystallize in a cooling body of magma will one day erode into sand, feed a river, and nourish the roots of trees. The volcano's stillness, then, becomes part of life's own rhythm. If one listens carefully to seismographs, the gentle lines tracing Earth's vibrations, a curious pattern appears. Low, harmonic tremors that precede many eruptions. These are not violent quakes, but the soft resonance of magma shifting within its chamber. Geophysicists sometimes describe them as drum beats, though they are more like a whisper through stone. Each tremor a syllable, each pause a long inhale. Such quiet persistence teaches something. That movement need not be loud to be powerful. The magma's patience is an instruction in endurance. How to hold energy without haste. How to prepare for transformation without fear. Even now, under sleeping volcanoes, magma pools and cools in invisible symmetry. The crust above thickens, forests grow over slopes that once burned, and all the while, warmth gathers again below. It is the planet's version of a heartbeat between breaths, silent but steady. If you close your eyes, you can almost sense that pulse, a slow, glowing drift beneath everything familiar. The next time you feel the ground solid beneath you, remember, it is resting, not frozen. The calm of the surface is woven from the patience of fire. Above the deep patience of magma, the crust of the earth drifts like a slow tide. To a human lifetime, it seems still. To the planet, it moves as rhythmically as breath. This motion, called plate tectonics, the rafting of continents across the mantle, is the mechanism by which volcanoes are born, destroyed, and born again. Imagine the planet as a vast mosaic of interlocking plates, each thousands of kilometers wide, floating atop a ductile layer of the mantle known as the asthenosphere. Here, convection currents rise and fall, carrying heat outward. The plates respond by gliding past one another, colliding or separating in slow choreography. Where they meet, the Earth exhales. Where they part, it inhales. At spreading centers, places like the Mid-Atlantic Ridge, new crust forms as magma seeps upward and cools in contact with seawater. The process is continuous, though invisible to the surface world. In a single year, the Atlantic widens by only a few centimeters, the rate at which fingernails grow. Yet those centimeters, sustained over eons, have split continents and shaped oceans. Elsewhere, plates converge. One slides beneath another in a process called subduction, where the lower plate sinks into the mantle and melts. From that melting rise arcs of volcanoes, the Andes, the Cascades, the islands of Japan. The pattern is ancient, elegant. As one surface descends, another is created. Nothing is lost, only transformed. It is easy to think of such power as violence, yet the scale of time transforms it into serenity. To the Earth, this exchange is as gentle as the rhythm of lungs. Each drift of a continent is an exhalation of warmth, each subduction zone an inhale of renewal. Over hundreds of millions of years, entire mountain ranges rise and dissolve, yet the planet's balance remains. Geologists have traced this breathing back nearly 3 billion years, using magnetic stripes frozen into oceanic crust as records of reversals in Earth's magnetic field. Each stripe marks a moment when new rock solidified at a ridge, recording the orientation of the planet's magnetic north. Together, they form a barcode of motion, evidence that the surface is always moving, always alive. Even now, satellites track this dance with astonishing precision. The Pacific Plate, for instance, slides northwest about 10 centimeters each year, carrying islands like Hawaii across a stationary plume of magma. Each island in the chain marks a moment in that journey. Kauai, the oldest, the Big Island, the newest, still glowing with birth. When one cools and drifts away, another takes its place. The pattern repeats endlessly. And yet, for all this grandeur, the motion of plates is silent. There is no audible creak, no groan of stone upon stone. Instead, the sound of tectonics is one of stillness, recorded only as faint vibrations, imperceptible to the senses. Beneath the hum of daily life, the world rearranges itself with infinite calm. The hypothesis threads through again, creation and destruction as one slow, breathing cycle. The continents rise and fracture, but their motion nourishes the planet's interior life. Without this breath, heat would accumulate, pressure would stagnate, and volcanoes, those luminous release valves, could not exist. The crust must move so that the earth can rest. From the hush of stone to the drift of oceans, the movement of plates is the quiet pulse of time itself. A rhythm beyond seasons, beyond civilizations. The ground beneath your feet, once buried under sea or glacier, will someday drift elsewhere, carrying the memory of all that has passed. As the planet continues its unhurried respiration, another story begins to rise. The emergence of new land where once there was none. From the edges of the seafloor, heat gathers for the next chapter of creation, the birth of an island. In the hush of the deep ocean, where sunlight fades to blue shadow, the planet's slow breath sometimes breaks the surface. From invisible fissures in the seafloor, heat and mineral-rich water surge upward, and out of that patient motion, new land begins to rise. The birth of an island is not an explosion, though it may seem so from above. It is a gradual blossoming of stone. At first, the process is unseen. Magma seeps through cracks in the oceanic crust, meeting water that is cold and immense. When molten rock touches that water, it cools instantly, forming pillow lava, round, smooth lobes that stack like bubbles of glass. Over centuries, these pillows build upon one another, a silent architecture of creation. When the mound grows high enough, it breaches the waves. Steam plumes rise, ash mingles with salt spray, and for the first time, air meets new earth. What was once ocean floor becomes shoreline. A volcano's summit, long hidden in darkness, greets the light. Scientists have watched this process in real time. In 1963, off the coast of Iceland, a submarine eruption gave birth to the island of Surtsey. From the sea came a black plume, then a ridge of ash and lava. Within days, the island stood several kilometers across, raw, steaming, utterly new. Over months it cooled and solidified, forming cliffs of basalt and beaches of fine volcanic sand. Today, Surtsey is a protected sanctuary, studied as a living laboratory of beginnings. What fascinates researchers most is not only the island's formation, but what follows. Within just a few years, seeds carried by wind and birds began to take root in the ash. Mosses spread, gulls nested. The island, once bare, began to breathe with life. From fire and salt water came a new ecosystem. The transition is the same story told again. Destruction as prelude to creation, heat becoming habitat. Every volcanic island carries this cycle within its stones. In Hawaii, each island was once a vent above a hotspot, a plume of heat rising from the mantle. As the Pacific Plate drifts northwest, each volcano cools and becomes dormant, even as another forms in its wake. Over millions of years, the chain extends across the ocean, a necklace of ages. The Big Island smolders. Kauai, oldest of all, sleeps under rain and forest. Seen from space, such islands trace the journey of Earth's patience. The ocean, too vast to hold in one glance, is patterned with these delicate stitches of land. Each marks a point where the planet reached upward and touched air. A quiet reminder that the boundary between sea and sky is always temporary. Geologists studying these islands find evidence of long cooling times. The cores of extinct volcanoes, once filled with molten basalt, have hardened into columns and domes. These formations, like the Giant's Causeway in Northern Ireland or the hexagonal pillars of Fingal's Cave, show the beauty of crystallized motion. As lava cools, it contracts and fractures into precise geometric shapes, a pattern written by mathematics and temperature. The result is both structural and serene. Nature's architecture revealed through stillness. There is a poetic truth here. New islands are born not from sudden fury, but from endless accumulation. Lava flows layer upon one another. Pressure yields form. Water sculpts the edge. The process never hurries. To the earth, each island is a slow exhalation, a moment of visible breath. Even after an eruption ceases, warmth lingers underground. Steam seeps from cracks. Minerals stain the rock in reds, greens, and yellows. These fumaroles are whispers from below, reminders that the island's heart is still warm, still listening. The hypothesis glows softly within this story. Creation and destruction are entwined, one gesture made of opposites. The ocean's cold depth receives the planet's fire, and from their meeting arises a surface where life can rest. As night gathers around this newborn land, the waves continue their rhythm against the black stone. Each crest cools what was once molten. Each retreat leaves salt upon the shore. Somewhere beneath, the magma shifts again, preparing its next slow rise. And so the earth breathes out once more, quietly, steadily, making room for what will come. When a volcano finally exhales, it does so in fragments of its own making. Tiny shards of rock, crystals, and glass that drift into the air as ash. To the eye, an eruption looks like destruction, a cloud tearing the sky. But beneath that drama is a quieter story, the return of minerals to the surface, the beginning of renewal. Volcanic ash is unlike ordinary dust. Each grain is sharp-edged, forged from magma that shattered as gases escaped. When seen under a microscope, these grains sparkle. Fragments of feldspar, pyroxene, and glass. Carried high into the atmosphere, they can travel vast distances before settling again, blanketing forests, lakes, and seas. What seems like fallout is in truth a gift of nutrients. In the months following an eruption, the ash darkens soil and alters its chemistry. Rain leaches minerals from it, potassium, phosphorus, trace metals, feeding the ground. In tropical regions, volcanic soils become some of the most fertile on Earth. Crops flourish where fire once fell. The green slopes of Java, the vineyards of Sicily, the rice terraces of Luzon, all are nourished by this cycle of ash and renewal. Scientists call this process weathering, yet the word hardly captures its grace. It is the planet's way of breathing between extremes, fire breaking stone, rain softening ash, roots weaving through what was once molten. Over time, volcanic dust enriches entire ecosystems, from alpine meadows to coral reefs. The same elements that burned the air return to build life again. Even oceans receive their share. Fine ash drifting over water sinks slowly, carrying iron that stimulates the growth of phytoplankton, the microscopic plants that form the foundation of marine life. These blooms absorb carbon dioxide and release oxygen, a quiet exchange linking volcanoes to the very air we breathe. The chain is elegant. Eruption to ash, ash to sea, sea to sky, sky to life. Historians have long noticed how civilizations grow near volcanoes despite their danger. The soil is rich, the rivers run warm, the landscape is abundant. Ancient peoples often interpreted this paradox as divine, gods of fire who destroy but also provide. In truth, it is geology performing its timeless balance. Destruction, creating the ground for sustenance. Ash also writes its memory into the planet's record. Each eruption leaves a layer in the crust, a delicate line in sediment cores that tells scientists when and where it occurred. By measuring these layers, a study known as tephrochronology, geologists can trace the rhythm of eruptions across millennia. The Earth, it seems, keeps its own diary in ash. In the still air after an eruption, when the last plume has faded and the sky grows pale, the scent of minerals lingers. On distant hills, Flakes of ash fall like snow, muffling sound. Birds return first, then insects, then the small green shoots that push through cooling rock. What was a wasteland begins again. The hypothesis breathes here. Creation and destruction are not sequential but simultaneous. The moment one ends, the other begins. The ash that darkens the sky today becomes the soil that feeds tomorrow. There is no pure ruin, only transformation at different tempos. Even now, scientists study volcanic ash to understand climate. Fine particles in the stratosphere reflect sunlight, cooling the Earth for months or years. Large eruptions have been linked to brief global chills. The year without a summer in 1816, the twilight glows after Krakatoa. The planet remembers each breath and adjusts. But beyond the data, there is something deeply soothing about this rhythm. To know that even fire can give rise to fertility is to see balance in its truest form. The volcano, after all, does not rage without reason. It exhales, then rests, allowing its ashes to become gardens. In your mind's eye, picture the gray slopes after eruption, still warm, faintly smoking. Then, months later, see them green again, the cycle complete. The silence returned. The Earth has breathed out, and now, in its long exhale, it breathes in once more. Every volcano, no matter how fierce its last eruption, eventually grows quiet. Steam fades, slopes cool, forests return. What remains is not extinction, but dormancy, a long, breathing sleep. To call a volcano extinct or dormant is to measure silence in centuries, not seconds. Some have slumbered for 10,000 years, yet beneath their calm, warmth endures. In this stillness lies a paradox of power. Dormant volcanoes appear as tranquil as hills, snow-covered cones rising above villages, their forms softened by erosion and time. People build homes along their bases, plant vineyards in their soil, name their towns after them. Yet inside, deep conduits remain, filled with mineral-rich fluids and faint tremors that hint at the living heat below. Mount Fuji in Japan, often painted as a symbol of serenity, has not erupted since the early 1700s. Its symmetry, near perfect, hides the restless history within. Layers of basalt and ash, each from a different century's outburst. Scientists listening through seismographs detect low, rhythmic murmurs beneath it, signs of magma slowly circulating miles below. It may not erupt for another 1,000 years, or it may awaken tomorrow. Either way, it waits in calm equilibrium. The same is true of Mount Rainier, of Taida, of dormant cones scattered across the Andes and the Mediterranean. They are called sleeping giants, not for their size alone, but for their patience. A volcano's rest is not forgetfulness, it is preparation. Magma chambers recharge, crustal pathways shift, gases accumulate or disperse. The process is slower than human history, yet continuous. A heartbeat stretched across millennia. To study this slumber, volcanologists use satellites and sensors that measure ground deformation. Even a shift of 1 centimeter can reveal movement below. Sometimes, a dormant volcano swells slightly, then subsides as if turning in its sleep. These subtle motions tell of magma refilling deep reservoirs, a reminder that stillness and motion coexist. There's comfort in that duality. The Earth, in its wisdom, spends most of its life at rest. Out of tens of thousands of known volcanoes, only a few dozen erupt each year. The rest remain silent, patient. Their silence is not emptiness, but balance. A long exhale after the bright work of creation. Culturally, humanity has always sensed this mystery. The Greeks imagined sleeping titans beneath mountains, Polynesian myths spoke of gods whose breath formed islands while they dreamed. In every story, rest follows fire, as night follows day. The volcano sleeps not because it is spent, but because it honors the rhythm of renewal. The hypothesis glows softly here. Creation and destruction, expansion and rest, all one breathing cycle. A volcano's dormancy is its way of keeping time with the planet. Even in stillness, it contributes to the balance of heat and motion beneath the crust. On quiet nights near volcanoes, people sometimes hear faint sounds, not explosions, but subtle rumblings. The Earth's voice speaking in frequencies too low to startle. These are called harmonic tremors, caused by the movement of fluids through narrow passages underground. Scientists record them and translate their patterns into sound, discovering notes that resemble a low cello hum, steady and soothing. The mountain, even while asleep, hums its lullaby. Over centuries, rivers carve through volcanic slopes, carrying minerals downstream. Fertile valleys form, towns flourish. Children play in the shadow of mountains that once reshaped continents. Life resumes, not in defiance of volcanoes, but because of them. The sleeping giant becomes a guardian, watching quietly over its green descendants. Yet in that serenity, there remains a humbling truth. No silence is eternal. One day, warmth will gather again, fractures will widen, and the mountain will breathe fire once more, not in anger, but in continuation, the way tides return or seasons renew. For now, though, the world rests under the moon's pale light. The giant sleeps. Steam curls faintly from vents like the breath of a dreaming creature. Snow settles on its shoulders. The earth holds its warmth close, waiting, perfectly still. Even when volcanoes sleep, the earth keeps whispering. Deep below the surface, the slow movement of magma, gases, and rock creates a symphony too low for human ears, a music of tremors that never truly ends. Scientists have learned to listen, translating those vibrations into sound and light, revealing the subtle language of a restless planet. Every tremor begins as motion. As magma shifts through fractures, it presses against solid rock, sending ripples outward. These ripples, seismic waves, travel through the crust like the resonance of a plucked string. Some are sharp and brief, others long and rolling. Together they form a pattern that tells a story of depth, density, and direction. To the untrained ear, an earthquake and a volcanic tremor might seem alike. But volcanologists distinguish them by rhythm. Earthquakes speak in sudden shocks, quick staccato bursts that end abruptly. Volcanic tremors, by contrast, hum in steady tones. They can last minutes, hours, even days. Each is a note in the Earth's deeper melody. Instruments placed around volcanoes, seismometers, tiltmeters, GPS sensors, record these vibrations. When their data are sped up and played as audio, the result is haunting. A slow, rising hum punctuated by delicate pulses, like the breathing of a cello. Before some eruptions, the hum becomes stronger, the tempo quickens. To scientists, it is both warning and wonder, the sound of magma finding its voice. This music of the earth is not destructive by nature. Most tremors occur far below the surface, where they dissipate into warmth. They are the gentle adjustments of a living system maintaining equilibrium. Just as your heartbeat fluctuates as you sleep, the planet too has rhythms that shift, calm, and renew. There is poetry in that parallel. The same frequencies that vibrate through volcanic rock often overlap with those of human physiological calm, between 1 and 10 hertz. Studies have shown that low-frequency sound can lower heart rates, synchronize breathing, and soothe the nervous system. The Earth, it seems, hums at the tempo of rest. When researchers deploy hydrophones, underwater microphones, near submarine volcanoes, the recordings capture an even deeper music. There are clicks and whooshes, distant rumbles, and tones that swell and fade like ocean waves. The soundscape is both eerie and tranquil, a lullaby composed of pressure and patience. Each bubble of gas rising from a vent, each shift of lava beneath the seabed, adds another soft percussion to the score. Ancient people, though lacking instruments, also heard this hidden song. In Iceland, low rumbles beneath volcanoes were said to be the growls of subterranean spirits. In Hawaii, the goddess Pele's voice was imagined in the trembling earth and sighing vents. In a way, both myth and science agree. The planet speaks in vibration. The hypothesis resonates here again: creation and destruction as one slow, breathing rhythm. The tremors are the in-between notes, bridging eruption and silence. They are proof that even at rest, the Earth remains in motion, its balance expressed as tone. Modern visualizations make this even more vivid. Computers convert seismic data into color and light, glowing waves that pulse across maps in time with the planet's vibrations. To watch them is to see the heartbeat of the world unfold. Red ripples bloom beneath volcanoes, fade and bloom again, like the chest of a creature sleeping under stone. And yet, beyond the science, there's a comfort in imagining the Earth as an instrument tuned to serenity. Every tremor, every quiet pulse beneath your feet is a reminder that stability is not stillness. It is motion held in harmony. So when the world seems silent, remember, beneath you the planet hums. Its song has no beginning or end, only rhythm, patience, and balance. The volcano listens to itself through that song, waiting until the time comes to rise again. Let that thought steady your breathing. Feel your own pulse slow to match the world's, a duet of calm between human and planet. Somewhere in the dark, beneath mountains and seas, the tremors continue, soft and unhurried, shaping the next whisper of fire. At first glance, fire and ice seem to belong to opposite worlds, one devouring, the other preserving. Yet on this planet, they often meet, shaping landscapes of rare and tranquil beauty. Nowhere is the contrast more profound or more peaceful in its paradox than in the quiet union of volcanoes and glaciers. In the high latitudes, Iceland, Alaska, Kamchatka, Antarctica, molten rock rises beneath vast sheets of ice. The heat of the Earth and the chill of the atmosphere share the same space, their boundaries constantly redrawn. When a volcano erupts beneath a glacier, steam rushes upward, melting ice into torrents that carve new valleys in days. But beneath the surface, the process is slow and delicate. The fire does not rage, it negotiates. Scientists call such systems subglacial volcanoes. They form when magma accumulates under thick ice, unable to escape freely. Pressure holds it back, forcing the molten rock to spread laterally, creating flat-topped mountains called tuyas. These shapes, found across Iceland's plains, are monuments to that quiet struggle, where fire rose, met resistance, and adapted with grace. In 1996, Iceland's Grímsvötn volcano, buried under the Vatnajökull glacier, awakened. For weeks, tremors built silently, muffled by hundreds of meters of ice. When the eruption came, much of the heat was absorbed, melting tunnels that carried glacial water outward in a sudden flood. Then, as quickly as it began, the volcano fell silent again. The glacier refroze. The land exhaled steam and returned to stillness. These events remind scientists how finely balanced Earth's systems are. The same forces that can unleash destruction also create equilibrium. The ice tempers the fire, while the fire reshapes the ice. The result is not chaos, but collaboration, a rhythm of transformation repeated throughout geological time. Beneath the Antarctic ice sheet, researchers have mapped over 100 hidden volcanoes, their peaks entombed beneath kilometers of frozen silence. Some are active, releasing warmth that influences the movement of the ice above. Others have been dormant for millions of years. Together, they create a delicate feedback. Volcanoes melt ice. Ice cools magma. The planet breathes through both. The interaction of heat and cold leaves remarkable signatures. When lava cools rapidly under ice, it forms hyaloclastite, a type of volcanic glass that glitters when fractured. Over millennia, these deposits accumulate, creating layers of colorful sediment. In Iceland's twilight summers, such formations gleam in hues of amber and violet, frozen evidence of fire's gentle patience. To those who study these places, the meeting of fire and ice is not a battle but a conversation. Each moderates the other. The glacier learns to flow differently when warmed. The volcano finds new paths when confined. Together they model balance, how opposition can yield harmony when time is allowed to do its work. And so the central hypothesis breathes once again. Creation and destruction are but two faces of one slow rhythm. The glacier sculpts, the volcano reshapes, and between them the land is renewed. The calm between eruptions is as essential as the eruption itself. When one stands near such a landscape, say at Iceland's Kverkfjöll, where fumaroles hiss beside snowfields, the senses encounter paradox made peaceful. The air smells of minerals and frost. The ground is warm underfoot while snowflakes drift through rising steam. It is a place where extremes coexist without conflict, where the planet reveals its deep composure. In myth, such places were seen as gates between worlds. The Vikings called them hell gates, believing that souls passed through the steam toward renewal. Today, science offers another kind of reverence. These are thresholds where the boundaries of solid and liquid, hot and cold, life and stillness, all blur into equilibrium. When night falls over a glacier-covered volcano, the ice glows faintly under the aurora. Beneath that shimmering light, magma stirs, not violently, but patiently, tracing invisible lines of warmth beneath frozen rivers. Above, the stars shimmer through clear, thin air. For a moment, the planet seems to rest between breaths. The Earth, after all, does not choose between fire and ice. It needs both, to cool, to warm, to renew. Their meeting is not contradiction, but completion. When the smoke clears and the Earth cools, what remains after an eruption seems lifeless. Slopes of gray dust, air still faintly bitter, streams running black with silt. Yet even here, in the quiet aftermath, the planet is already at work rebuilding. Life, it turns out, is drawn to volcanic ruin as surely as it is to rain and sun. The first arrivals are often invisible. Microbes drift in on the wind, carried from oceans, forests, or distant soils. They settle into cracks of newly cooled lava, feeding on minerals that to us seem barren. Some use iron or sulfur instead of sunlight, performing a kind of dark photosynthesis. These extremophiles, lovers of extremes, are living archives of adaptation. Their presence on fresh volcanic rock tells a deeper story. Life does not merely endure destruction, It begins with it. Scientists studying new islands like Surtsey or regions around Mount St. Helens after its 1980 eruption have witnessed this progression firsthand. Within months, lichens and mosses began to colonize the warm, porous stone. Their roots broke down rock into fine dust, creating the first soil. Insects followed, then birds, and finally plants, small at first, then forests. The sequence unfolds not with urgency, but with quiet inevitability. Volcanic ash, so recently the symbol of desolation, becomes the perfect nursery. Its rough surface holds water, its minerals feed roots. Where lava once flowed, grass and flowers take hold. The green returns faster than logic might predict. Within a decade, the once scorched landscape hums with pollinators. The air smells again of chlorophyll and rain. In this pattern lies the Earth's quiet genius, using the residue of fire as the foundation for renewal. Ecologists call it primary succession, the birth of an ecosystem from bare rock. It mirrors the earliest stirrings of life on Earth itself, when volcanic coasts and hydrothermal vents provided the chemistry that made cells possible. What began as geology became biology through patience alone. And so the hypothesis deepens. Creation and destruction are not separate acts, but two halves of the same breath. Each eruption clears the way for new growth, each layer of ash a cradle for what follows. The mountain burns, then blooms. In the volcanic highlands of Indonesia, people speak of this cycle as a promise. The ash that covers their fields one year ensures abundant harvests the next. In the Canary Islands, pine forests evolved thick bark and cones that open only after fire, turning catastrophe into renewal. Even humans, unknowingly, mimic this rhythm. Rebuilding cities, replanting gardens, returning to slopes where ancestors once fled. Biologists who study these rebirths often find species found nowhere else on Earth. On the flanks of Hawaiian volcanoes, tiny silver ferns and insects adapted to warm ash fields exist only in the narrowest bands of altitude. Life uses the planet's extremes as its palette. From heat and ash come forms delicate enough to be erased by a single step, yet strong enough to begin a forest. In time, as soil deepens and roots spread, the memory of eruption fades. A hiker passing through a lush valley may never guess that the ground beneath once glowed red. But the chemistry of that soil, the balance of silicates, iron, and trace metals, continues to shape every blade of grass. Even the sweetness of fruit carries the fingerprint of the volcano that nourished it. Seen this way, the ashlands are not scars, but seeds. The Earth's slow handwriting across its own surface. From each burnt plain rises a new chapter of growth, just as from each night comes morning. As twilight settles over a cooling field of lava, steam curls like breath from cracks in the rock. The air is warm against the cooling wind. In that mingling, life begins again, quiet, unseen, inevitable. The volcano resting now has done its part. Its destruction was never final, only a gesture in the long rhythm of creation. When a volcano exhales, its breath does not stop at the horizon. Fine particles, light enough to float, rise through layers of air until they reach the upper atmosphere. There, they drift for months, sometimes years, circling the globe in invisible ribbons. The sky remembers every eruption, painting its recollection in color. After large eruptions, Krakatoa in 1883, Mount Pinatubo in 1991, sunsets grew unusually vivid. Painters of the time described skies streaked in crimson and violet for years afterward. The science is simple yet poetic. Aerosols, tiny droplets of sulfuric acid formed from volcanic gases, scatter sunlight differently. They bend red and orange wavelengths around the curve of the planet, creating twilight that lingers long after the sun has set. These luminous evenings are the planet's way of recording change. In the quiet after destruction, the sky softens, diffusing memory into light. What the ground loses, the atmosphere preserves, a diary written not in stone, but in color. From orbit, satellites capture these veils as faint hazes surrounding Earth. They drift like threads of silver mist, stretching across hemispheres. The air, which seems so empty, becomes a global mirror for volcanic breath. Eventually, gravity and rain bring the particles down again, completing the long return from sky to soil. The process, though invisible, has weight. Volcanic aerosols cool the planet by reflecting a fraction of sunlight back to space. After Pinatubo's eruption, global temperatures dropped nearly half a degree Celsius for 2 years. The planet exhaled warmth, then inhaled calm. Even the atmosphere participates in the same breathing rhythm that governs fire and stone. But the sky's memory is not only chemical, it is emotional too. The way colors after an eruption can quiet the mind. People in 19th century Europe, seeing Krakatoa's sunsets, wrote of a strange peace, an awareness of the planet's vastness. Artists captured the glow without understanding its origin, as if the Earth were trying to soothe itself through beauty. Scientists studying ancient ice cores find thin layers of trapped ash and sulfate marking eruptions long past, each layer a frozen echo of sky and fire. Time capsules preserving how the world once breathed. These traces help reconstruct not just the history of volcanoes, but of climate, migration, and change. The air, it turns out, is an archive written in whispers. There is a quiet paradox in this. The same eruptions that darken days also deepen nights, making sunsets glow and stars shimmer through clearer air. In the wake of fire, the planet finds a different kind of stillness, a balance between light and shadow, between warmth and reflection. And so the central hypothesis breathes again. Creation and destruction are one continuous motion. What the volcano releases in heat, the sky transforms into calm. The two are partners in equilibrium, one exhaling, the other absorbing. When evening comes after an eruption, the air carries a faint metallic scent, the trace of sulfur and dust. As the sun dips, the colors bloom, first gold, then rose, then a deep, tranquil violet. For a few minutes, the whole horizon glows as if lit from within. Then, gradually, the light fades and the world cools back into blue. The planet's pulse slows, its memory stored in silence once more. There is something soothing in knowing that even the sky keeps record gently. It does not hold grudges or wounds, only traces of transformation. Each eruption, once terrifying, becomes another layer of atmosphere, another tone in the evening's palette. And when we look up at twilight, unaware of which volcano gave the color to the clouds, we are witnessing not aftermath, but continuation. The planet painting itself calm after fire. In that moment, as the first stars appear through violet haze, the earth seems to sigh. The memory of flame has become light. Since the first humans looked upon the glowing horizon, volcanoes have been both mystery and mirror, symbols of power, creation, and the strange calm that follows upheaval. Before seismographs or satellites, long before the language of magma and plate tectonics, there was only awe, and awe, like gravity, has always drawn us closer. Imagine early people watching fire pour from a mountain's crown. To them, the sight must have been divine. the earth itself speaking in light and thunder. The air would vibrate with heat, the sky turned copper, and yet, afterward, life would return richer. Crops grew stronger in the ash. Springs ran warm and clear. The message was unmistakable. Destruction carried its own healing. Across cultures, this dual nature inspired stories. In Polynesia, the goddess Pele ruled both fire and creation, shaping islands with her molten touch. The Greeks told of Hephaestus, smith of the gods, forging beauty from flame beneath Mount Etna. In Japan, Mount Fuji became a bridge between worlds, a calm, sacred presence that embodies endurance. In each myth, volcanoes were not punishers, but artists, sculptors of land and time. Even today, these myths whisper through science. Geologists describe the same balance, though in the language of convection and chemistry. The planet, too, forges in fire. New crust born from old, elements recycled, balance maintained. Awe, once clothed in story, remains in the data, a feeling that transcends the centuries. Standing near an active volcano, the sensation is unmistakable. The air trembles, the ground is warm, sound seems to vanish, replaced by a low hum felt in the chest rather than heard. Many scientists describe the experience as humbling, even meditative, as though witnessing the heartbeat of the planet itself. Mount Stromboli in Italy has erupted continuously for over 2,000 years. Locals call it the lighthouse of the Mediterranean. Its steady glow, visible from sea, has guided sailors through dark waters for generations. What might have been terror became reassurance, a reminder that the earth, though fiery, is faithful. The hypothesis shines here like embers beneath ash. Creation and destruction are part of one slow, breathing earth. Humanity's awe is our recognition of that rhythm. We see in volcanoes not chaos, but continuity. The same balance that governs tides, seasons, and breath. Anthropologists studying communities living near volcanoes often find reverence, not fear. Shrines appear along lava flows. Festivals mark eruptions with song and prayer. These rituals, born from survival, become expressions of peace. People learn to live with uncertainty by making it sacred. In Indonesia, villagers near Mount Merapi bring offerings of rice and flowers to its slopes. They call the mountain Grandfather. Each year, they thank it for fertile soil, even as they remember its danger. Their gratitude is quiet, practical, and profound, a philosophy shaped by geology. Artists, too, have long felt drawn to this paradox. Turner's sunsets, born from volcanic ash in the sky, shimmer with melancholy beauty. Poets describe eruptions as the Earth's heartbeat breaking through the crust. Musicians mimic their rhythm in slow crescendos, ending not with climax, but with release, an echo of magma rising and cooling. Science explains, art remembers. Both are acts of awe. Both are ways of listening. And perhaps that is what awe truly is, listening without the need to control. Volcanoes teach us that not everything fierce must be tamed, that some power exists only to remind us of patience. When one stands before a dormant cone at dawn, mist curling from its summit, silence heavy, awe arrives not as fear, but as calm recognition. Here is a being older than memory, slower than time, endlessly patient. Its warmth sleeps under frost. Its next breath may come long after we are gone. In that stillness, the volcano and the observer share something unspoken, the understanding that transformation is natural and that beauty often follows upheaval. The heart slows, the air warms, awe, like lava, cools into peace. Before instruments, before charts and satellites, there were only eyes. quiet observers watching the faint glow of distant peaks through the night. Long before volcanology became a science, it was an act of wonder, of stillness. People did not only fear volcanoes, they watched them, learned their moods, and without realizing it, began to read the language of the earth. The earliest written accounts of volcanic activity are almost tender in tone. Roman historians described Mount Etna not as a monster, but as a teacher, a mountain that revealed the world's inner fire. Ancient Chinese scholars recorded the color of smoke and the direction of ash, noting that each variation seemed to herald a different weather. Across the Pacific, Polynesian navigators used the glow of distant eruptions as signals, markers on the horizon guiding them home. Observation, even then, was a kind of reverence. When you watch something immense long enough, fear dissolves into rhythm. The volcano's unpredictability becomes, paradoxically, predictable, a pattern of pulses, silences, and sighs. The watcher learns patience, matching breath to magma's tempo. Centuries later, when science emerged from superstition, that same quiet watching became method. In the 1600s, Jesuit priests on Mount Vesuvius began keeping detailed logs of eruptions, sketches of lava fountains, measurements of ashfall, notes on tremors that preceded each burst. These were not yet scientific by modern standards, but they were deeply human, attempts to listen more closely. By the 19th century, volcanology was born. Instruments replaced intuition, but the spirit of observation remained unchanged. At Stromboli, the lighthouse of the Mediterranean, scientists camped for months, counting explosions per hour, measuring gas plumes, recording their glow on photographic plates. Each observation was an act of patience, of awe translated into data. Even today, volcanologists speak of their work in almost meditative terms. To study an eruption is to surrender to time, to accept that hours or days of waiting may yield a few moments of insight. Instruments hum quietly, seismographs tracing delicate lines, spectrometers catching the light of sulfur's flame, cameras watching the night for a shift in hue. The mountain teaches by degrees. At Kailauea in Hawaii, researchers keep vigil through the night, monitoring the lava lake's surface. It moves like breath, rising and falling with subterranean gas. When the level drops, they know the vents are closing. When it rises, the pressure builds. The glow reflected on clouds becomes both warning and comfort. Even from afar, islanders watch for that red shimmer on the horizon, knowing it speaks of life as much as danger. The hypothesis hums here again. Creation and destruction, study and stillness are not opposites, but companions. Observation itself mirrors the volcano's rhythm. Long waiting, brief revelation, then rest. The scientist, like the mountain, practices patience. In recent decades, cameras placed along crater rims transmit live images to the world. Millions can now watch eruptions unfold in silence from their screens. Yet despite the distance, the feeling remains the same. Calm fascination, a sense that the Earth is performing its slow ritual. Even digital observation becomes a kind of collective meditation. At night, when the glow reflects on low clouds, the colors soften. Not garish red, but ember orange, like candlelight behind fog. The scene is strangely peaceful. The sound of the wind, the hum of instruments, the slow rise and fall of the crater's breath, all merge into a rhythm that feels like heartbeat and tide combined. Early explorers, sitting at the edge of lava flows, wrote of time dissolving in that light. Hours passed like minutes. The mountain's glow seemed eternal, steady as a star. Some fell asleep beside it, lulled by the soft hiss of cooling rock and the warmth that radiated even through the night air. Watching, they became part of the stillness they studied, and so it continues. Century after century, watchers and volcanoes exchanging calm. Observation has never been about control. It is a way of listening, of allowing the planet to speak in its own slow cadence. If you were there now, standing at the safe edge of a glowing field, the air warm against your face, the night full of quiet crackles, you might feel it too. The ancient peace that lives in every eruption's aftermath. The glow, soft and steady, holds the same message the Earth has whispered since its beginning. That change, even fiery change, can be tranquil when time moves slowly enough. When a volcano speaks, it does not use words. It exhales. From vents and fissures drift plumes of vapor and gas, thin, white, and transient, like the planet's own breath against the sky. To the untrained eye, smoke is smoke, but to those who listen closely, each curl, each shade, each scent carries meaning. The volcano's whispers can be read, and their language is older than speech itself. Most volcanic gases are invisible. Water vapor, carbon dioxide, sulfur dioxide, hydrogen sulfide. They rise in different ratios depending on the depth and temperature of magma below. A plume rich in water tells of magma near the surface, releasing its moisture as it cools. A plume thick with sulfur signals pressure building below. Scientists now treat these emissions as sentences, fragments of the Earth's dialogue with its own sky. Instruments called spectrometers measure the sunlight absorbed by volcanic gas. From that faint difference in color, researchers can calculate the amount of sulfur dioxide escaping each day. Before major eruptions, that number often surges, the planet exhaling a little too fast, as if preparing for a deeper breath. On clear days near Mount Etna, the plume rises like a ribbon, unfurling gently across the Sicilian sky. Pilots flying overhead use it as a compass, a slow-moving landmark. Locals can tell by the hue, ivory, gray, or faintly blue, what mood the mountain holds. The language of smoke is subtle but universal. It speaks of balance and release. In Kamchatka and Chile, remote sensors now watch volcanic gases from orbit. Satellites capture ultraviolet signatures invisible to the human eye, tracing the Earth's size across continents. The data forms a kind of planetary calligraphy, tendrils of vapor curling in patterns that change with wind and time. When scientists visualize these flows, they resemble brushstrokes on air. Gentle, patient, deliberate, yet long before technology, people understood this language intuitively. Shepherds near Vesuvius once judged the day's weather by the mountain's breath. Polynesian fishermen read distant plumes as omens of tides. The ancients were not wrong. Volcanic gases influence both air and ocean, shifting winds and clouds in ways they could feel, if not name. The hypothesis breathes quietly through this translation. Creation and destruction are one dialogue, one exchange of breath. Smoke and sky are not enemies, they are partners in release. The volcano exhales, the air receives, balance resumes. Modern volcanology listens more gently than ever. Sensitive microphones called infrasound sensors detect vibrations below human hearing, the deep notes of gas escaping vents. These sounds, when amplified, resemble a low, steady hum. Each volcano has its own signature tone, a kind of identity expressed through frequency. Scientists speak of them almost as voices, distinct, rhythmic, and calm. During calm periods, a volcano's plume is a sign of peace. It allows pressure to dissipate slowly, preventing explosive buildup. In that way, smoke is not warning, but wisdom. a reminder that quiet release sustains equilibrium. The earth teaches, in vapor and wind, the art of exhalation. Standing near an active vent, one can feel the air warm and moist, scented faintly of minerals, sharp but clean, like rain on hot stone. The plume drifts upward in spirals, carried by invisible currents. Watching it, time seems to slow. The motion is effortless, without rush or sound, the visible shape of balance itself. Artists and poets have often compared such plumes to incense, the earth's offering to the sky. In a sense, that metaphor is literal. The gases that escape form new clouds, seed rain, and enrich distant soils. Every exhalation, no matter how small, enters the planet's cycle of renewal. At twilight, when the air cools and the plume grows faint, its last wisps catch the sunlight, glowing pink and gold before fading into dusk. The mountain rests, its message delivered. The language of smoke is patience. It says, "Nothing endures by holding breath forever." It reminds the world, and perhaps us, that release, done slowly, is the purest form of peace. Beneath the waves, far below sunlight's reach, the earth still breathes fire. Along the seams of the ocean floor, where tectonic plates drift apart, molten rock seeps upward in a slow, glowing dance. It hardens instantly on contact with seawater, creating new crust, an endless renewal hidden from view. This is the mid-ocean ridge system, a continuous chain of volcanoes that circles the planet like a quiet heartbeat beneath the sea. The water above presses down with immense weight, more than 1,000 atmospheres at the deepest ridges. Under such pressure, eruptions make no sound, no roar, no plume of ash. Instead, lava flows silently, forming bulbous shapes known as pillow lavas, each one a frozen ripple of movement. They accumulate mile after mile, building mountains no eye has seen. Where magma meets water, something remarkable happens. The heat drives seawater into cracks in the crust, where it circulates and re-emerges as hydrothermal vents, fountains of mineral-rich fluid, shimmering like smoke in the darkness. Around these vents thrives an entire ecosystem, one that exists without sunlight. Instead of photosynthesis, life here depends on chemosynthesis, bacteria converting chemical energy from the Earth's interior into food. These microbes are the foundation of an undersea forest of sorts. Giant tube worms, ghostly white and crimson-tipped, grow meters long. Shrimp with reflective eyes swarm through black clouds of mineral dust. Mussels and crabs cluster along vent chimneys that rise like cathedral pillars. It is a garden born of darkness and heat, proof that life can flourish wherever the planet breathes. Scientists believe that such places may mirror the conditions where life itself began. Billions of years ago, before oxygen filled the air, early oceans were rich in dissolved metals and gases. Hydrothermal vents provided warmth, stability, and the chemistry necessary for self-replicating molecules to form. The first cells may have risen from the same volcanic breath that still warms the sea today. In this deep communion, the hypothesis finds its quietest truth: creation and destruction as a single pulse. The same forces that fracture the crust also feed new life. Fire becomes cradle, and the cold of the ocean becomes its shelter. Modern oceanography has given us glimpses of this serenity through remotely operated vehicles. Their cameras descend into the blackness and reveal a world of muted color. Blue light reflecting on metal, slow drifts of particles glowing like dust in starlight. From the vents rise black smokers and white smokers, columns of water laced with iron and silica. They pulse gently, each exhalation a breath of the earth, Even in the absence of sound, there is rhythm here. Sensors record temperature changes that oscillate like tides. The flow of vent water quickens and slows in response to distant earthquakes or the turning of tectonic plates. The planet, even at the bottom of the ocean, moves in patterns of inhale and exhale, and there is silence, vast, soothing, complete. No storm, no wind, only the slow murmur of bubbles and the faint crackle of cooling lava. It is the kind of silence that feels alive, resonant. One could imagine that if peace had a place of origin, it might be here, where fire and water have learned to coexist in perpetual calm. Explorers who have visited these depths often describe an unexpected emotion: tenderness. Surrounded by heat and darkness, they find fragility instead of menace, a delicate ecosystem balanced on the edge of molten stone. Even the vent chimneys, some taller than buildings, are ephemeral. They grow as minerals precipitate, then collapse and reform, breathing in rhythm with the planet's heat. Each vent field is temporary, yet renewal is constant. When one closes, another opens elsewhere. The cycle repeats quietly, infinitely, sustaining life that will never see the sun. The ocean's surface shimmers with sunlight, but deep below, the glow comes from within, from the slow fire that began long before the first dawn. If one listens closely, perhaps through imagination alone, the undersea world hums with the same music that tremors through mountains and plains. Low, steady, patient, it is the sound of a planet alive and gentle, a rhythm that has carried both fire and life for 4 billion years. The sea, in its depth, remembers the beginning. The volcano, in its warmth, continues to whisper it. Together, they keep the planet breathing quietly, endlessly. After every eruption, there comes a silence, the long, unhurried phase when the Earth exhales warmth into the night and begins to rest again. This is the time of cooling, a process not measured in minutes or hours, but in centuries. The lava that once glowed red against the dark sky hardens slowly, releasing its stored heat grain by grain, crystal by crystal. The violence has passed. Only patience remains. Cooling begins at the surface, where contact with air or water draws out the first wave of heat. The outer crust blackens, then dulls to gray, while beneath, molten rock still moves, sluggish, glowing, reluctant to stillness. For weeks or months, that inner current pushes and settles, forming hollow tubes known as lava tunnels. Long after the eruptions end, these tunnels may stay warm enough to melt ice, their walls coated with glassy minerals that sparkle in torchlight. Within a few years, what was once a fiery river becomes stone. But the transformation is not abrupt. Crystals grow inside as the molten mass cools unevenly, aligning themselves like frozen ripples. Basalt, andesite, rhyolite, each mineral pattern a record of time's passage, a map of how the mountain learned to rest. In some places, the cooling rock contracts into columnar joints, tall hexagonal pillars that stand like the pipes of a silent organ. The Giant's Causeway in Northern Ireland, the Devil's Postpile in California, and the cooling flows of Iceland all share this geometry. Each column, perfectly straight yet born of chaos, is the Earth's signature of order after fire. To walk among them is to stand inside time itself, solidified. Cooling also reshapes sound. Fresh lava hisses and crackles, then slowly even that fades. The air grows still. Birds return. Rain begins to fall on the darkened slopes, its drops releasing soft steam. Over months, cracks widen, moss settles, and the surface, once sharp and alien, begins to soften under touch. The volcano's heat has not disappeared. It has merely hidden deeper, becoming warmth instead of flame. Beneath cooled flows, residual magma remains hot for decades. Geothermal vents, gentle cousins of eruptions, carry its warmth upward through fissures. In Iceland and New Zealand, this heat now powers homes, lights cities, fills pools where people float beneath the sky. Energy once born of destruction becomes comfort, sustaining rather than scarring. In these places, the hypothesis feels almost tangible. Creation and destruction are two halves of a single rhythm, and rest is the space between them. The volcano, having spent its strength, now teaches endurance, how to remain warm without burning, alive without movement. The chemistry of cooling is quiet and precise. As temperature drops, elements that once flowed freely begin to bond. Silicon with oxygen, iron with magnesium, weaving the architecture of minerals. Crystals of olivine, feldspar, and pyroxene appear like stars in solidifying night. Under microscopes, thin slices of basalt reveal these constellations frozen mid-formation, beauty preserved in structure. The same minerals that harden here will someday weather into soil, feed forests, and anchor roots. Time's patience ensures continuity. The volcano, by cooling, becomes cradle once again. In a few hundred years, rain will carve canyons through the black rock, revealing bands of color: rust from iron, green from copper, white from salt. Each hue is memory. Each fracture, a line of history. Even the silence that settles afterward is full, layered with echoes of motion now stilled. To sit near a cooling lava field at dusk is to witness serenity made visible. The air shimmers faintly with the last trace of warmth. Beneath your feet, the rock radiates a low, steady heat, neither fierce nor fading. The mountain seems to sleep in place, its glow withdrawn but not gone. The planet knows this rhythm well. Every cycle of eruption ends not in ruin, but in renewal. Every storm followed by stillness, every flame by rest. The cooling earth reminds us that peace is not the absence of energy, but its gentlest form. And so the night deepens, the stone cools, the warmth remains within, quiet as breath. The volcano has spoken, and now it listens once more. Beneath every mountain, every ocean, every inch of soil, the planet keeps a rhythm, an invisible pulse that connects fire to air, stone to sea, and life to all that came before. To listen for it is to imagine the earth as one great organism, its magma, the bloodstream, its volcanoes, the heartbeat made visible. Each eruption, each slow exhalation of gas is not chaos, but circulation. This pulse is driven by heat flow, the steady movement of energy from the core outward. Deep within lies a sphere of molten iron spinning faster than the crust above. Its motion generates the Earth's magnetic field, shaping the compass and shielding the planet from solar winds. From that core, warmth rises through the mantle, lifting matter in convection currents that move continents like leaves on a slow tide. Volcanoes are the places where that pulse surfaces, small openings in a vast system, allowing the planet to release heat with grace rather than violence. Without them, pressure would build endlessly. The crust would crack unpredictably. The Earth would struggle to breathe. Geophysicists measure this internal rhythm not by sight, but by numbers. Tiny sensors buried in rock detect temperature gradients and seismic waves. Satellite imagery reveals surface deformation, while thermal cameras capture faint infrared glows invisible to the human eye. Together, these observations reveal a pattern as regular as a resting heart. Energy rises, dissipates, renews, over and over, age after age. The scale humbles the mind. The planet's interior contains more energy than all its surface storms combined. Yet that energy is released with remarkable composure. An exhalation here, a ripple there, never frantic. On average, the Earth loses about 44 terawatts of heat into space each year, enough to power civilization many times over. But instead of burning, it sighs it away through volcanoes, ocean ridges, and the soft radiation of warm stone. In that patience lies balance. The hypothesis glows again. Creation and destruction are two halves of one breathing cycle. The pulse of the planet is proof. It sustains oceans, builds continents, and shapes climates, yet all through calm repetition. This rhythm is ancient. 4 billion years ago, the young Earth pulsed faster, its surface a molten sea. Over time, as heat escaped, the tempo slowed, the crust thickened, the oceans cooled, the heartbeat softened into steadiness. What we experience now, earthquakes, eruptions, tides, are merely the quiet echoes of that once turbulent beginning, the pulse of maturity replacing the chaos of youth. Even the carbon and water that sustain life follow this rhythm. When volcanoes erupt, they release carbon dioxide and water vapor, gases that once lay trapped in the mantle. Over eons, these emissions built the atmosphere, feeding the greenhouse warmth that keeps the planet habitable. Later, through weathering and photosynthesis, the same gases return underground, completing the loop. Life and geology breathe together. In Iceland, geothermal vents trace this connection visibly. Steam rises from cracks in the earth, powering turbines that provide energy without harm. The heat that drives those turbines is the same that forged continents and kindled early life. Humanity, at last, has learned to borrow from the planet's pulse without breaking its rhythm. If one could listen through miles of stone, the Earth's hum would not be silence but song. Scientists have, in fact, recorded this faint vibration, the seismic background noise of the planet. It is continuous, omnipresent, created by waves, winds, and the deep murmur of magma. It oscillates in patterns that shift with seasons, with tides, even with lunar pull. The Earth sings softly to itself, and volcanoes are its high notes. To feel that is to find calm. For even in our own bodies, the same logic applies. Heartbeats, breaths, circadian rhythms. Each sustains balance through repetition, not speed. The planet's pulse, scaled to its size, mirrors our own. To sense it is to remember that we, too, are made of earth, warmed by the same fire, cooled by the same rest. As night deepens, imagine that pulse beneath you, not danger, but reassurance. The ground's faint warmth is the echo of a system older than stars, a rhythm that has never failed. Somewhere below, magma flows like slow light. The continents drift in unison, each movement part of a timeless dance. And above it all, life sleeps, breathing in step with the earth. The planet endures because it balances itself. Every rise meets a fall. Every burst of fire finds its cool reply in rain and time. Beneath the seeming chaos of volcanoes and quakes, an exquisite symmetry holds. Heat flows outward, gravity draws inward, and between them, the crust remains whole enough for life to rest upon. Volcanoes remind us that creation is never separate from correction. When magma builds mountains, erosion softens them. When plates collide to lift continents, wind and water grind them down again. Over millions of years, this dialogue of opposites keeps the surface alive, never static, never lost to either stillness or storm. Physicists describe the Earth's interior as a thermodynamic system, energy rising, dissipating, reforming. Yet what those numbers conceal is grace. The energy of eruption is answered by the calm of sedimentation, the noise of fire by the hush of decay. Nothing persists without its counterweight. Consider the volcano itself. Its shape depends on balance. Gentle eruptions produce broad, low-shield volcanoes, like Mauna Loa, born of steady, fluid lava that flows without violence. In contrast, steep stratovolcanoes like Fuji or Cotopaxi arise where pressure builds and releases in measured bursts. Each form, serene or fierce, emerges from the same equilibrium between gas, magma, and time. Even destruction has proportion. A single eruption may seem cataclysmic, yet compared to the Earth's scale, it is but a breath, one correction in an ongoing equation of temperature and pressure. The crust breaks only to heal differently. Lava cools, forming rock that strengthens the surface once more. This balance extends outward. Ash in the air dims sunlight and cools the climate. Later, that same ash enriches soil and spurs new growth. Ocean ridges create seafloor crust, even as subduction zones consume it. The planet loses and gains land at nearly the same rate, keeping its surface area constant through eons. Nothing is wasted, nothing truly lost. To humans accustomed to shorter rhythms, this slowness feels eternal. Yet the harmony is delicate. If eruptions ceased entirely, the Earth's interior heat would accumulate, stagnating like breath held too long. If they became constant, the crust would thin, and life could not anchor. The current balance, quiet interrupted by release, is what makes stability possible. Here, the central hypothesis breathes anew. Creation and destruction are not rivals, but the same current moving in opposite directions. One builds pressure, the other releases it. Together, they sustain the planet's poise. Erosion, too, is a gentle force in this conversation. Rain dissolves minerals, rivers carry them to sea, volcanoes one day recycle them back to land. The hydrologic and geologic cycles weave into one great fabric, each motion compensating the other's excess. Over ages, the mountains you see now will become sand, and from that sand, future mountains will rise. The balance of forces is not limited to Earth's crust. It reaches into the atmosphere and ocean. Volcanic gases influence climate, but climate, in turn, shapes volcanoes. Heavy rain infiltrates cracks, altering pressure within magma chambers. Ice caps weigh down crust. When they melt, the land rebounds upward, awakening long dormant vents. The system listens to itself. Even life contributes. Forests capture carbon released by eruptions. Marine plankton use nutrients from ash to grow. Their shells later sink, storing carbon in the deep sea. The living and the molten are one conversation, constantly recalibrating. In this exchange, there is neither victory nor defeat, only continuity. The volcano's roar becomes the ocean's calm. The mountain's fall becomes the valley's bloom. Each energy returns home through transformation. To sit within that understanding is to find stillness. The forces that shape continents also shape peace. Stability is not the absence of change, but the presence of perfect proportion. As twilight fades, imagine standing at the edge of a cooled crater. Wind brushes past, soft but persistent. The air smells faintly of minerals, of rain on rock. Somewhere deep below, warmth stirs, not rushing to rise, only existing, balanced and patient. The Earth has spent billions of years learning this lesson, to burn and to cool, to rise and to rest. Its calm does not come from stillness, but from symmetry. And in that symmetry lies serenity, the quiet assurance that no matter the upheaval, equilibrium will find its way again. To study volcanoes is to study ourselves. Their rhythm, the patience of stillness, the necessity of release, mirrors the hidden cycles within every human life. We too hold warmth beneath calm surfaces. We too transform through quiet tension and gentle renewal. The mountain's breath and the breath in our own lungs are more alike than they appear. Deep below our calm expressions, energy gathers, thoughts, memories, emotions, molten and fluid. We carry pressure in invisible chambers, hopes waiting to rise, grief waiting to cool. When we repress too long, something inside begins to move, searching for release. In this, we are small volcanoes of feeling, our eruptions not of lava, but of words, art, and understanding. Psychologists sometimes describe emotion as energy in motion. It must circulate or it stagnates. In the same way, the planet's fire must move upward to keep its interior alive. When we allow our inner magma to rise, through creativity, through kindness, through expression, we mirror the planet's quiet genius, turning heat into growth, turmoil into renewal. Ancient peoples sensed this correspondence intuitively. In many traditions, volcanoes symbolized both destruction and creation, wrath and rebirth. The Hawaiians saw the goddess Pele as both temper and tenderness. The Romans associated Vesta's sacred flame with domestic calm, the same fire that could destroy cities if unkept. Each myth carried the same understanding, that fire's moral lies not in its power, but in its balance. Modern science echoes that wisdom. We know now that volcanic cycles depend on release. Slow emissions of gas, gentle tremors, steady warmth. Without these, pressure builds until eruption becomes inevitable. The same is true within. To speak softly, to create, to weep, to love, these are human vents, keeping balance through gentle expression. The hypothesis glows warmly here. Creation and destruction as one continuous pulse. What the volcano teaches is not avoidance of heat, but harmony with it. Passion, after all, shares its root with fire. Both illuminate when tended, and both consume when denied air. Artists, poets, and thinkers have long found inspiration in this parallel. Van Gogh's swirling skies after Krakatoa's eruption, the tremor in Beethoven's late sonatas, all echoes of volcanic emotion rendered into beauty. Eruption turned to art. Pressure turned to peace. The human heart, like magma, does its best work when allowed to move slowly and surely toward release. And just as the planet cools after its outbursts, so too do we need the time of rest that follows intensity. A mountain does not erupt endlessly. It pauses, rebuilds, breathes. After passion comes reflection. After grief comes silence. The cycles of our inner landscape are as natural as those of the Earth's crust. This mirroring extends even further. The chemistry of our blood, its iron, its sodium, its trace magnesium, all originate from ancient volcanoes and the mantle's molten forge. The minerals that let us think, move, and love are gifts of deep time. We are, in a literal sense, fragments of cooled lava walking and remembering. To realize this is to feel less separate from the world. The same pulse that moves continents moves through our veins. The same heat that melts rock once powered the lightning that fused life's first molecules. We are born of that rhythm, shaped by it, returned to it with every breath. So when life feels unsettled, when change comes fast, or silence stretches long, it helps to remember the volcano's calm. Beneath its sleeping slopes lies energy beyond measure, yet it rests untroubled, waiting for the right moment to act. The planet is patient with itself. We can be too. In mindfulness practice, the breath becomes the body's volcano. Inhale, pressure, exhale, release. The process never ends and never should. It is balance sustained by motion, peace maintained by gentle change. At dusk, when the air cools and the last light touches mountain peaks, the reflection is clear. The world outside and the world within share one heart. Fire and patience, eruption and stillness, creation and rest. To see the volcano clearly is to understand the self gently. Both are living stories of transformation written across time. The earth, though ancient, is not finished. Beneath its calm crust, the slow fire continues, patient, gathering, ready to write new shapes into the surface. The continents drift, the mantle circulates, and magma, ever restless, waits for the smallest permission to rise. The story of volcanoes is not only history, but prophecy. A reminder that creation is ongoing, that the future itself is still warm. Scientists can now trace these hidden preparations. Satellites record tiny bulges in the ground. Seismic instruments detect whispers of gas and liquid miles below. Each signal tells of potential, not immediate danger, but continuation. The same processes that built the first lands will build the last. Some of the next eruptions are already rehearsing their parts. Beneath Yellowstone, a vast magma chamber breathes slowly, its heat spreading through geysers and hot springs. In Iceland, the mid-Atlantic ridge pushes upward, forming new fissures that may one day surface as islands. Along the Pacific's fiery rim, ancient volcanoes refill their veins with molten light. None of this unfolds in haste. The Earth's patience is infinite. Even if human eyes were gone, the cycle would go on. Magma rising, cooling, crumbling, rising again. Long after today's mountains have eroded into plains, new ones will emerge from the sea, as others once did. The planet's story is written not in permanence, but in repetition. This continuity is not ominous. It is comforting. The hypothesis endures. Creation and destruction are the same motion, seen from different distances. The next eruption is not a break from peace, but a renewal of it. Fire rebalances what time erodes, restoring energy to the crust and chemistry to the sea. In laboratories, geologists melt rock under controlled pressure to understand what tomorrow's magma might reveal. The data suggests subtle change. The mantle's composition shifting slowly as continents recycle through subduction and uplift. The Earth is evolving, not toward an ending, but toward complexity. Even humanity participates. Our tools and cities depend on volcanic gifts. The basalt in roads, the pumice in gardens, the rare elements in electronics. Future fire, when it comes, will provide again, not as catastrophe, but as raw material for whatever life follows. There's quiet poetry in that thought, that the mountain which one day glows on a distant horizon may already exist beneath our feet, invisible, unborn. The same heat that formed the earliest oceans will guide the last. Time's circle remains unbroken. Some scientists dream of harnessing geothermal power on grander scales, of drawing the planet's warmth gently instead of forcing it. Such visions reflect a deeper harmony. Humans learning to live not against the Earth's energy, but alongside it. The volcano, once feared, becomes teacher and ally. In this imagined future, perhaps centuries ahead, settlements may cluster near controlled vents, drawing light and heat from steady magma flows. Green valleys will thrive where the ground still breathes. Children might learn that the Earth's interior is not something to dread, but to understand, a steady heart beneath their world. Meanwhile, the old volcanoes will continue their quiet work. Each dormant cone will gather warmth in silence. Steam will rise faintly from fissures at dawn, and somewhere in the ocean's dark, a new island will begin, unseen, unhurried. To imagine such futures is not to predict disaster, but to honor persistence. The planet's endurance exceeds every crisis. It adapts, reforms, rebalances. Its story is not of endings, but of endless return. When astronomers study distant worlds, Mars with its extinct volcano Olympus Mons, Venus with its vast lava plains, they search for signs of what we still possess. A planet alive enough to move, to breathe. Our Earth, still restless, still renewing itself, remains rare in the universe. That restlessness is a gift. It keeps the oceans circulating, the continents fertile, the atmosphere alive. It keeps us connected to the fire from which we came. The next volcano, whenever it rises, will not mark an ending, but a heartbeat. Proof that the Earth remains young at its core. And as the surface cools under night skies, the warmth beneath persists, patient as always. The planet dreams of future fire, and in that dreaming, it remains alive. Even when the surface grows cold, the Earth never truly cools. Beneath mountains and oceans, warmth lingers, not as flame, but as memory. These are the eternal embers of the planet, the quiet glow that has burned since its birth, sustaining motion, shaping landscapes, and whispering continuity through time. The outer crust may sleep, but the interior remains awake. Within the mantle, temperatures still reach more than 1,000 degrees Celsius, enough to melt rock and stir continents. That heat is the same ancient energy born from Earth's formation, joined now by the slow decay of radioactive elements, uranium, thorium, potassium, the planet's hidden hearthstones. They burn without light, releasing warmth atom by atom, keeping the deep stone alive. This gentle fire explains everything visible. Rivers flow because mountains rise. Mountains rise because the interior remains warm. The magnetic field hums because molten iron turns in the core. Life endures because the planet's pulse never stopped. Without those embers, the surface would stagnate, the oceans freeze, and the breath of balance would fall silent. Geologists once called Earth a heat engine, a phrase too mechanical for what it describes. The truth is more intimate. The planet carries a core of quiet fire, steady and generous, radiating through layers like a heartbeat through skin. That warmth does not seek to escape. It simply moves upward, cooling with patience, ensuring continuity rather than collapse. In this glow, the hypothesis finds its fullest form. Creation and destruction, eruption and stillness, all are expressions of the same warmth, enduring through change. The volcano, even extinct, carries embers within. A mountain that seems asleep may still release soft steam at dawn. Each hint of heat, each mineral spring, is the Earth remembering itself. Some of this heat now rises as comfort. Geothermal pools in Iceland, Japan, and Chile shimmer under cold air, drawing people to soak in what was once the mantle's fire. In their stillness, they feel connection, not to danger, but to lineage. The warmth beneath their skin is the same warmth beneath the crust. The Earth lends its calm to those who pause long enough to feel it. Even art and architecture echo this continuity. The basalt columns in old cathedrals, the obsidian blades of ancient rituals, the pumice that floats light as air, all remnants of molten time, transformed into human touch. We live surrounded by cooled fire, walking each day across the relics of heat that once built the world. Scientists estimate that it will take billions more years for these embers to fade entirely. By then, the sun will have changed, and the Earth's story will have evolved beyond us. Yet the idea of that slow cooling is strangely peaceful. The knowledge that nothing burns forever, but neither does it vanish suddenly. Even endings arrive by degrees. When we look at stars, we see the same truth reflected outward. Suns live and die as the Earth does, their energy recycled into new light, new planets, new warmth. The cosmos, too, keeps its embers, galaxies glowing faintly in deep time. The universe and the Earth share one instinct: to keep warmth alive as long as possible. Standing at the edge of a dormant volcano under night sky, one might sense this kinship. The air cools with altitude. The ground still holds faint heat. Beneath that surface, slow currents stir, unchanged by centuries. Above, starlight travels across eons. The mountain and the stars both whisper the same thing: nothing that burns beautifully ever truly ends. These eternal embers, quiet and unseen, are what make the planet gentle. They teach endurance without haste, transformation without loss. In them, fire finds peace, and time finds meaning. And as those embers glow within stone, they glow within us too. Warmth that endures through every silence, every cycle, every night. At the end of every story the Earth tells, there is light fading into calm. The glow of magma softens to amber, then to gray, then to darkness. The mountains cool, the air clears, and what once roared settles into silence. This is not an ending, but a deep exhale, the cooling light that follows every flame. From space, the planet appears serene, blue, white, and green, turning slowly in the quiet of its orbit. Yet inside, warmth still flows. The volcanoes we have followed across these hours, from ocean ridges to sleeping giants, continue to hum below the surface. They no longer burn with fury, but with balance. The same fire that forged the crust now glows invisibly, a steady thread tying every rock, every forest, every breath to the first dawn of Earth. If you could see through stone, you would find no stillness, only peace in motion. 1,000 slow rivers of heat drifting upward, feeding life, shaping continents. And on the surface, all appears calm. That is the planet's secret. Serenity not from absence, but from harmony. The hypothesis rests quietly now, proven by time itself. Creation and destruction are two sides of one breathing Earth. The fire that once consumed returns as warmth. The ash that once darkened sky becomes soil. Even silence is another form of sound, slowed beyond hearing. Nothing is ever wasted, nothing truly gone. The planet does not rush toward perfection. It lingers in renewal. In the hush of night, perhaps you can feel it beneath you, the faint heat of the world's heart, the pulse beneath the crust. It is the same rhythm that steadied the first oceans and will steady the last. Between your heartbeat and the planets, there is no distance. Both move in the same patient pattern. Inhale, exhale, rest. Volcanoes, once feared, reveal their true lesson here at the end. That the universe keeps its calm through transformation, that fire and stillness are one continuum. To see that is to find rest not only for the mind, but for the soul. So let the warmth fade gently. Let the light dim. The Earth is breathing evenly now, and so are you. All things that rise must cool, and in that cooling, they find their peace. The volcano sleeps. The planet dreams. The ember glows softly in the dark. Good night.